Alright, what's good, yo? I literally forgot to post yesterday because this was on private for this entire time. But you can probably see the date. It's gonna be true today. It's not gonna be August 16th. So you may wonder why there's 2 videos posted today, but it's not really 2 videos. It's more like I forgot to post it yesterday's. But it's fine. Alright, let's keep it going. Find the city with the smallest number of neighbors at a threshold distance. Okay, this looks like dikstras. There are n cities from 0 to n minus 1. Okay. Given the array edges where edges I from 2 and the weight represented bidirectional and weighted edge from I and 2, and given the integer distance return the city with the smallest number of cities, small number of cities that are reachable through some path whose distance is at most distance threshold. If there are multiple cities, return the city with the greatest number. Return the city with the return the city with the smallest number of cities that are reachable through some path and whose distance is at most distance threshold. If there are multiple cities, return the city with the greatest number. Notice it's all the ways. Okay. What? So there's 7, 8, 9, and there's 1. Okay, so the figure above describes the graph at distance thresholds 4 for each city are city 0, 1, 2, 1, 0, 2, 3, 2, 0, 1, 3, 3, 1, 2, city 0 and 3, 2 cities at threshold 4, but we have return city, that's the greatest number. City 0, 3, and 0, 0, and 3 have 2 neighboring cities at distance threshold 4. But we have to return cities to the greatest number. Okay. But, okay, what? City 1 and 2. City 0. I don't get this. This is kind of complicated. Figure above describes the graph neighboring cities at distance threshold. What's the thing? I don't understand what distance threshold. Return the city with the smallest number of cities that are reachable through some path and whose distance is at most. Okay, at most. Okay. Oh, I see. So, okay. How can you reach to city 0? Well, I can take starting from city 2, city 1, and that's valid. Right? That's still 4, right? Okay, how do I reach to city 1? 1 second, I gotta do my laundry. Okay, so now I understand. So what's the shortest path to get to city 2? Well, we can take we can get to 2, so we can get to 0, 1, 3. Wait, what? 0, 1. Wait, what? City 2, I can go to city 0, city 1, and city 3. What? That doesn't make sense at all. City 0, city 1, city 3. How does that make sense? That's like 7 right there. What the fuck? City 0, 3 have 2 neighboring cities at threshold 4, but we have to return city 3 since it's the greatest. Alright. The figure above describes the graph. The neighboring cities at a threshold 2 for each city are city 0, city 1, city 2, city 3, city 4. The city 0 has a neighboring city at threshold 2. Who we have to return city 3 since it's the greatest number. I don't get, what are these saying? Discuss the graph. The neighboring cities at distance threshold. This was the smallest number of cities that are reachable through some there's some path whose distance is at most. I don't get how 2 is on here though. Right? Because if we take city 0, then we take city 1. Wait, hold on. If you take city, how do we even get to 1? You take city 0. Boom, that's 1. Okay. Or you can take city 2 and you go straight to it. Or you go straight to, oh, okay. They're not like path. They're just like individual. You can start from city 1, city 3, or city 2, and you go straight to city 1. And they all are valid. Okay. So city 1, so city 3 here, right? Why is this valid? So we can, how can I, this is, let's say this is the target, so we can start trying to, can I get to here? Is that good? No. Can I go here? That is valid, but is that threshold? No, so disregard that. Or we start here and go straight there, boom, that's 1. That is in our threshold. And then we can go, wait, so city 2 can go straight there, and yes. So I guess we have to keep like some map, right? Right, we have some map where 3 and 2, right? We literally need to have like some default dictionary. We have like a dictionary with with all these cities, and then we return the highest number. Wait, city 0 and 3 have 2, oh, actually not the highest. Return the highest number with this, okay, well actually go through the who has the smallest one. So it's gonna be 0, 3, the smallest list, right? Yeah, okay. Then, okay, so I need a way to fill up this like thing here. I guess we could do like a priority queue. Is there like a priority queue or no, it's not priority, it's like just use a heap. You know? we could do a heap here and then we can heapify this. So okay, we're gonna build out our edges, right? So first we're gonna do is process everything. We need to process all the nodes in the graph. Okay, so what do we need to do? We need to build a graph. We'll make a, I guess we'll do this, right? We have graph here. For every UV weight in edges, graph of U and V graph of V U, but I need to know the weight. So let's append where it goes and the weight. And the weight. Right. Right, so we're gonna have a graph of all this, and then we need to, the figure above describes the graph. The neighboring cities at distance threshold 4 for each city are. Okay. So now I need to kind of make another like thing and call like BFS or like dikstras, right? Okay, so like we build a graph and then we have to do like def, I guess dikstras. BFS. I'll do like something like this, right? And then we're gonna do a Q, right? Right, and we will. Okay, we'll start with our source, which is source. And obviously it costs 0 to visit wherever you start at, right? And we need a visit. All right, let's go scene, set, and then we'll start BFS while Q. Let's do cur equals q dot pop. Oh no, we're gonna do heap pop because we need to use a priority queue for this instead of a normal pop queue, right? And then right, heap pop queue. Then we will, okay, we pop that out. Then we need to process it. So scene, I guess we can say, we say, node weight right? We'll say node weight, and we'll just add the node scene dot add node. Well, I guess not node. We'll call it a city. Visit or a city, and city. Okay, we add the city. And it's just see how many I can like basically visit. Yeah. Okay, so then now we check its neighbor for every neighbor in graph of city, right? Then okay, we're gonna do if let's say we already visited it, right? So if neighbor not in scene, right? And we want to make sure that we only add, right, if our current weight plus this neighbor is a little bit more loaded. Neighbor is a 2 tuple, right? We have next city and next, let's call next like this, next city and next weight from neighbor. So if next city not in scene and if next city not in scene and next I guess current weight plus next weight is less than equal to distance threshold. Yeah. Then we can scene dot add, or not scene dot. We could do heap push this queue onto this thing with this value neighbor, right? So yeah, perfect. Right, so we process that, and then we'll eventually visit return length of scene -1, because we want to exclude like this because it doesn't make sense, right? We don't count it. You don't count yourself. You don't count yourself. So that's good. It's not really by BFS. It's like dikstras, but dikstras is basically BFS, but with parity here. But anyways, so then we do for every I in range of n, right? We will call BFS at source, which is node I, right? And it's gonna return us how many cities are reachable to source, which is I guess we could say city, right? How many cities are reachable? So this is, we're gonna have I see. So res is the city, and min city is also 0, right? Or I guess float infinity or something. So we need to update 2 of these at the same time because we will return res, right? But we need, so basically if min city is less than, or if, okay, if this city, I guess, number city, or neighboring cities, right? We have this min city, which we call BFSI, which return that. If neighboring cities, right? If neighboring cities is less than or equal to min city, then I guess only less than, and then neighboring city. Oh, spelled it wrong. Right? Oh my god. Neighboring cities equals BFSI. If neighboring cities equals less than min city, res equals min city, right? Right? Not min city. The actual city itself, like the city node number, and then neighboring cities. We have to keep track of min city, which is neighbor. Right. So. Okay. So that should work. Okay. That was pretty straightforward. Let's try this now. Brother. Key error. U.pen vu. Oh fuck! I forgot this is not a default dictionary. Default list. Oh, I meant to say city. Ooh, okay, this is good. Yeah, this is basically BFS but weighted. Oh, never mind. Okay, I think I got Chile or something. It's too slow. Well, that sucks. Oh, I just got a wrong answer. Oh, okay. Maybe it's my res. Like, should I be returning city 0 all the time? No, that makes sense, right? That's weird. Am I doing my BFS wrong? If next city non-seen and weight plus next weight is less than equal to distance threshold, heap push. That sucks. So we have min city, res city, and range. Neighboring cities equals BFS city. If neighboring city is less than min city, then min city is the new main. That and res is equal to city. I don't know what's wrong. Let's see, bro. Okay, so like if okay, I feel like I should rework this. This is a pretty long line. We should probably skip the city, like if city in scene, just skip it because there's no point of like going forward. Okay, it's a little better, but I'm getting the wrong. Should it be like, oh yeah, I have to do the greatest one. Yes, it has to be the minimum. If it's equal, yeah. So if I find another one that fits the criteria, oh no, that's fine. That doesn't change anything. Oh, a lot better. It is. That makes a huge difference because it like even if it's equal, we want to update that latest one, right? Yeah, makes more sense. Okay, so now we're just off by how many more? 3 test cases. We got 28 instead of 27. So what am I doing wrong, guys? Help brother out here. Help brother out. VUUVW. Yeah. I know I'm doing something right. So if neighboring city equals BFS, call that and call this less than equal to the min city. Min city, sure, and then we update that and we return that. Okay, so res equals. I guess we do max of res at city. Same problem. I think it's just inherent when you do that. Okay. I'm missing something. Weight plus distance threshold less than or equal to the threshold, then we add those to the thing. I don't know. I don't know. This bug is weird. Wait, I might have an idea. Hold on. I need to read the documentation. Heap ordering for tuple. If compares to oh my god, bro. Okay, that's why. Okay, now I'm prioritizing city ID. That's not good. But now everything's flopped. So hold on, I'm gonna peel this apart. Wait and next city. Next wait. Right, and I want to add this next, I guess, next weight and next city. Bro, that's such a stupid, oh my god, that's probably why I broke this. It would, okay, now everything's broken. What? I want to prioritize the weights, right? That's what I'm keeping track of, right? Weight plus next weight. Oh wait, next, no, this is the city though. It's a city. Next city. It comes out next city, next weight, right? But I have to order them. Next city, next weight. But I order them differently. Yeah, that's what I do. What? No way. Because this wouldn't be altered. This is this city and the weight. City, weight. Weight plus next weight less than equal to. Oh my god, now this is gonna be messed up, right? So this is gonna be weight city, yeah. Please. Oh my god, that's even worse now. Are you serious? What? That makes no sense at all. I guess we can have none here. What is happening right now? If the neighboring city is less than or equal to, yeah. I'm so confused. Okay, and I'm adding this correctly, right? I'm starting with the weight and the next city. Also, skip if I've already seen the city. Oh my god, I'm gonna go insane, bro. Weight plus next weight less than equal to distance. That's just heap push Q next weight next city. Neighboring cities less than equal to cities. Min city equals neighboring cities. Res equals city. Oh my god. UV VUW. So put that there. Oh my god. Alright, I'm looking at the answers. Oh my goodness. Wait, what is this? Dikstra's down. Wait. Sylvester Stallone. Yes, we have the same thing. Good. If Colonel not visited. Next city in next weight. If distance to this node, weight plus next weight, right, is less than equal to that, then add it to the queue. Put the weight. Oh no. We're supposed to put the current weight, right? No. What? Oh no. We're supposed to accumulate. So that's weight plus next weight. Yeah, that's what I thought. Yeah. We're supposed to accumulate. Brother, that is such unfortunate. I thought the weight it gives would be accumulated, but it's not. But anyways, alright, thanks for watching. I'll see you guys for more. Peace.